Hi everyone. So who out of you uses authentication in their app or projects? Yes, everybody, right? Who likes it? So there's a problem, right? When you start a project, no matter what, you always need like these thick layers of authentication and permission and reset your password and emails and so on. So let's try to be more modern than that. So there exists something that's called the JWT, so JSON Web Token. I'll talk about first about me. So my name is Aurélien. So I'm CTO at Descartes AI, and we do AI for software development teams. So one of our products is this. This is a screenshot of Jira. So we do estimation of effort, estimation of time for every ticket, like is it done in 2 weeks, in 1 month, and so on. So AI for companies. Now, to GWT. So first thing, it's a standard to communicate claims between two parties. So with two parties, this is the important part. Gonna go to the website, to their website. So yeah, what do I say? Is it readable at all? What do I say? It's a self-contained token. I will show you an example. So one token contains as much information as you need. It's used for authentication and they call it information exchange. So authentication is the usual case where the user sends his password, gets back some token, and then with each request sends the token like cookies usually. But it's more generic than that, so you can use it for exchanging information about claims. So you can have one server knows something and wants to communicate it to another one that are not necessarily connected, and can exchange it like that. You can also exchange information with your future self, right? When you generate a token and then you get it 1 hour later, and you can say, okay, this was my decision, like securely. So what does it look like? First, it uses JSON, which is a big point. I mean, it's for the web, right? So they use JSON for everything to make it simple to implement. So you have an implementation for every language because it's pretty easy. There's 3 parts, a header, a payload, and a signature. So the header looks like this, just says information about the token itself, like which algorithm is used to sign it, and the expiration date, that kind of things. There is the standard specify the list of fields. Then the payload is the second part, is what you can customize, is your claims. We'll see that. And you have the signature. So the signature, they support mostly two modes, one with a symmetric key, like HMAC, and one with a RSA or asymmetric key. And they also support elliptic curve and things like that. So the 2 modes. I'll come back to it. So it looks like this. It's base 64 encoded, so you never have problems. I can pass it in URLs, in whatever. It's base 64. They have very nice thing on this website. They have this debugger where you can just paste a token here, and it's going to just unpack it and verify the signature and so on. And it works the other way as well. So you can change something and it's going to re-sign it so that you can test, make a quick test. Because this is all about making applications quickly. Right? So we have nice tools. And then the standard way of using it, well, once you have it, so I'll come back to it. Standard way is to pass it as a header like this. So you have a token, make a client makes a request with authorization, standard thing. So that was it. So in code, in Node, what does it look like? It's a pretty straightforward API. So there is You can have two servers, so of course it can be the same server if it's a simple application. Very simple sign function. You have to manage the key, so that's your responsibility to store the secret key somewhere and pass it to your application still. And here, at this part, you put everything you want. So at least you have a username normally in it. You can have permissions, so you just make whatever you want, like permissions and some array, or you can have easy to, as the user paid for the premium plan, that kind of things. Then on the receiving side, so the application server that processes actual business logic, you have an express integration. You have integration with everything else as well. And it's a middleware that verify the token, takes it from the header, verify the signature, and raises an error if it's wrong, or passes you the content that was there, like this username, is like on the request objects in Node Express. So it's simple. The advantages of the approach. So it exists for a long time. This kind of approach, it's called signed cookies. So where the cookie is not a random string that you have to look up in a database, but the cookie contains the data, the claim, we say, and it's signed by a secret key. So the point is to avoid having a database infrastructure and maintaining tables and having to make a lookup every time and this central piece that is the database. That's the big complexity in an application. It's always the stable part, the database. So for many applications, you can get rid of it by using a signed token instead, or signed cookies. Now the GWT, it builds on that, but it's a standard. So you have lots of applications, lots of implementation for it. You have many services that use the same one. Well, that's the whole point. So with that, you can decouple the authentication. So that's validating the user password and such from the authorization. So the authorization is, does this user have the right to do this? So you can decouple them like this. Different servers, different services, different companies managing both things. So you're writing the app and you can let someone else build the authentication. You can build a decentralized architecture because you don't need the central database and central login server. And there are more cloud services possible. Notable applications. So there is a Firebase, is the big one. Firebase is a database, a storage, and analytics. It's like a turnkey service to make applications, like mobile applications or web. And they use JWT to authenticate the user and to remember which you can customize it as well if you want to have a group or permission and such. There is a Google Identity Aware Proxy, which is part of their cloud platform. So it also uses JWT. It's like a proxy that checks if the user is authenticated with his Google account. If not, it goes to the normal Google login. And if it is, it forwards to your app with a signed token for your app. And then your app, you use the verify, and then you have the username, the email, and such things so that you can build only the logic. You have Atlassian Connect, for instance, for Jira and such to make add-ons. So it's like they combine kind of your page in an iframe or other things, other services. So they use it to give you permissions, restricted permissions from a user with a token and all the fields inside saying what your plugin or your add-on can do. So they use it for the flexibility because it's a JSON, the payload, the claim is a JSON object, so you can put very, very flexible claims. And then there is Auth0. So Auth0 is the company that started it. So they implemented the first version and wrote the standard, and they run the website. And it's an authentication service. It's authentication as a service. So as I said earlier, if you have a cool idea for an app or you want to start quickly, it's very nice to drop the whole authentication part and the OAuth with Google and Facebook and all that stuff, and running your database of users and all of it. And all the security issues that come with it that are numerous and complicated. So you can have authentication as a service that just does all of it. So it talks to the providers like Google and Facebook and log in with GitHub and all of them at once. It also manages the accounts, manages the login per email and password. So sending the emails, the I forgot my password emails, all of that. So you can have it just in 5 minutes. And they have a UI as well. So in JavaScript and also mobile UIs. So the same, you don't have to implement the validate, but it's an email and everything. So you have two main choices. It's Auth0. They are specialized with that. They do only login, and they have lots of features like to see your list of users and remove them, or can make rules and all of this, and other integrations with other cloud services. And you have Firebase, which is integrated, so they have an authentication part as well, based on jailability. So for instance, this is one product of my company. So this is the standard Auth0 login. This is just like one line to copy paste, and you have it like this with a password and with the social providers, and they manage everything. So much faster and more secure. You can use it for other things. That was for authentication. One nice application is for the OAuth state parameter. So if anyone has ever implemented OAuth to request permissions from Slack, for instance, or others, and you have to go through the flow of OAuth, which is a little bit ridiculous, and you always you have the state thing that is optional, but if you don't use it, it's very insecure. So you need to either you have a database session where you generate a random state and you store it, and then you verify it when you get the callbacks. Instead, you can just use a signed token in this state. So for those not familiar with OAuth security, there's this guy, Omakov. He explains so many times that he broke GitHub and Twitter and such, and hundreds of websites that don't implement OAuth properly, because it's quite tricky, quite funny as well. Another application that we use at Descartes is the magic links, like invitation links. If you want to send an email, so you have this link, invite with a very long token. So you've seen that probably from many services, and you can do it like this. So the URL is a big token that says what you can do with the link. So that's very, very easy to implement it. You just do, like I showed earlier, this sign, and you get the token, and you build your URL with it. And then users can share it to share what they want to give as permissions. And you put in the payload what it is about. Also the URL, like sharing the documents, and do something when you click in an email, like all those long magic links. And you can reuse it for if you want to make an API for your own service, you just reuse the token as well. The same architecture, the same everything. Instead of having a separate API key and cookie session system, just reuse the API token. Or you let the user generate API token with fewer permissions. So you just remove some permissions from your claims, and you give them this key, and that's the API key that can do this. So also otherwise tricky to implement when you want to choose the permissions and make API keys. That's very simple with GWT. Security is an issue always. So the early days of JWT, that was also a little bit ridiculous. You have this header. I showed the three parts, and the first part is the header that says how it's signed. So you can just forge one, and there is an algorithm that is none, but is just do not verify. And the first implementations were just not accepting anything. So you just do it with no signature, and you can do everything. That was a little scandal. A little bit more tricky, but the same principle of having this header that is not trusted, and it says how you should validate it itself. That issue was when you use an asymmetric key. So you have a public key and a private key. Private signs the token, and the public one is not that secret. Maybe you publish it. You will use your certificate or something. And then the attacker can say, oh no, actually my token is symmetrically signed. And the key is the public key that was supposed to be the asymmetric one. I don't know if that's clear, but yeah, the implementation, the library that verifies, it just obeys the header and uses the symmetric algorithm. And of course, the public key is known. So that was an issue. There's the reference here explaining those issues. Yeah, now it's fixed in most implementation. But still, you should set the header. So actually, the header is mostly useless, to be honest, in this standard. You should set what you expect in the verification part. You should set the parameters, the options. So what algorithm you expect, and only this one. So it's not going to depend on the header. If it's a different one, you just reject it. You can also specify key ID, and you have other parameters that you can set. So everything that you know, just set it, say I want this and nothing else, and then you avoid many issues. On the website, jwt.io, they have a list of all the implementation with what they support and what they do verify. So you can check yours and which version is like not ridiculously broken. So starting from 4.2 for nodes. So always check your libraries for everything. Now storing the token in the web browser. So they use local storage in all the examples. In general, the standard is local storage, but I recommend using cookies anyway, because cookies have security features in the web browsers, and local storage has no feature. So you can set the cookie with, for instance, this HTTP only here that says if you have a cross-site scripting vulnerability on your website, at least with this option, your token cannot be stolen. So the attack is not persistent. You can set that. Every browser supports it. You can set secure to avoid having this token traveling without SSL. So that's why I recommend using cookies instead of the local storage. And then so the standard, the default is to use HTTP headers. But if you're going to use cookies for this, there is a little trick in the Node implementation. There's this get token that you have to use and say to take the cookie as a token instead of the header. I also prefer the asymmetrical signature. So with this algorithm, this is also the one that Google and all use and recommend, because then you can be a little bit sloppy with the public key. On your app servers, you don't need to manage secrets. You always have this problem, right? You have your source code, and then you have your secrets, and you don't know if you should put it in Git or not. So the public key, I think, is perfectly fine to have it in your source code, in your repository, and that's it. So it's easy to deploy. You deploy with no secrets. Only the login server or whatever service does the authentication needs the private secret. So that's more flexible. One thing you cannot do is repudiation compared to using a database to store sessions. So you cannot instantly say kick this user out. If there is some abuse in your particular application, you will need a blacklist. Of course, you will need some sort of database or some file if you have this problem. By any chance. And there is another evolution, which is less widespread, but very interesting. It's called Jose. So in the GWT, you have your payload, but it's not encrypted. If the user opens the console of his web browser and you can see how it's done, like what's in his token, it's just JSON. If you want to have a secret, so give the user a secret and that he cannot read it, there is another standard which is called Jose that is both signed and encrypted. So you have your claims inside of it. The user cannot read it because it's encrypted, and you of course cannot forge it because it's signed. And that was it. Do you have any question? Maybe I went a bit fast. Yes?
Okay. The first question, you suggested to use cookies over the local storage, saying that the only, I mean, say this as you've done it, and the mainstream to your website can treat that. But the point of GWT is you have available. So your website is just knows about the user. So like username, like any information you have, user roles, everything. But now with HTTP only, even user can treat anything. So what's the point of the GWT in place? So just a cookie, and that's it. They will be automatically sent to the server. But client cannot read that. Yeah. No, we can't. Go server using the details about
Yeah.
Yeah, but I mean, you sign the whole information which can leak.
So if you want to do that, if you want to use...
Can you quickly repeat the question for the next time?
Yeah, so the question is when you use the cookie flag HTTP only, and then your client side cannot read it anymore. So if you want to do it like this with having this session, I mean, you might as well store this kind of information in local storage, for instance, if it's browser-based data. Otherwise, when you have other information, they come from the server anyway. There is something happening on your server, or your third party, your Firebase and such. So typically, you want the token still not too big. I mean, it doesn't contain all data ever. It contains the authentication ones, the permissions, the username, and such. Otherwise, you would use local storage if you want it to use it as a session, and every time the session changes, you regenerate a token, and then you store it in local storage. Yes?
You talked about not using the header for, let's say, for stating the algorithm for the connection. And you said that it would be some sort of configuration. Is it in the payload then, or in the last part of the parts of the
No, it's in your option. So
the options are located here?
It's right here. So here you can add more options.
Okay.
So you say if you know that you are going to use this algorithm only, you put it here. So if you don't put it, the implementation is trying to auto-detect. And that's the issue.
Best effort.
Yeah. So it auto-detects. They have some hacks. They try to see, does it look like a RSA key or not, and things like that. So instead here, you know your algorithm, you put it here. And there are also other parameters that you can put. There is an audience parameter, which is to avoid if you have several services that should not be allowed to, you should not interpret a token as the other from one as the other. You can also verify this here.
This is then a key value pairs, right? It's a list of key value pairs then?
Yes, it's the option for the libraries. It's documented in each library. Any other question? Yes.
I would like maybe we could go a little bit deeper into what is the most shared information with the payload. Because the importance of the transparency, that this actually information is publicly accessible to the public, depending whether you store it as storage or whether it's stored as a cookie. But I'm also publicly by different parts of the platform independently. What is the most used data you put in the payload? Let's say your use cases. It's not only sometimes not only username, right? And ID. Sometimes add more additional data which might be used by other services. Mentioned very Facebook premium account. In terms of your implementations, are there any additional data that you are storing?
So the question is, what data can you typically store in the payload? So besides user ID or email and such, one thing that we store in our application is what I call the team ID. So because we work with teams, so each our token in Descartes, they contain the list of all the teams that you belong to. So it's an array with all the teams, and then you can make requests to our backend or also to our Firebase, and it's going to check that the team data that you requested appears in this your list. Another example, as I mentioned, the magic links and the OAuth. So in that case, the payload is it also contains still user ID and in our case team ID, and you can add action. So what action does the token represent? Like connect something. Now I mentioned Slack integration, for instance. So when we do the authorization flow with Slack, and in the URL there is a token with the action, what it is that which team is trying to connect what to what, so that it cannot be spoofed. So that's another example. Any other question?
One more.
Yes.
Actually, cookie versus local storage, because
Yeah.
we're looking into the same thing for a while, and there's a limit, right? The limit is the size of the cookie and the size of the header you can set.
That's right.
Have you ever noticed before that actually the amount of data you are putting in the payload never get close to it?
No, so can the token get too big because it's sent on each request? Well, it's ours token, they are like 1 kilobyte, so it's 1 extra kilobyte per request. I think it's pretty low compared to the big Google and Facebook and so on that just send like so much data, breaks your data plan in one day. But then, yeah, if it's that big, because it's really meant for authentication and authorization, so it should be like lists of permissions and such. Maybe list of friends or other things that could get big. But at some point, you do need a database for that data. But you can use cloud services. Then it becomes the question of cloud versus hosted. But no, I guess bandwidth is cheap enough nowadays. It's cheaper, it's more performant to transfer 1 kilobyte or 2 kilobytes than to make a database request on your server regarding latency.
I have a question to the thing. I
Yes.
still don't quite get what's the benefit of storing it into the group. Does that mean that the client, if I understand this correctly, that the client cannot call an API that's on a different server because it doesn't send the JWT with it?
Yeah, with different domains, in that case, you cannot do it. You would have to send it or set it off each domain. So in that case, you cannot use it. The question.
The benefits of JWT is that you can just stop anything.
Yeah, in that case, you would store it differently, and you cannot get the benefits from the web browsers. But if you control everything, it's your domain, then you can use it. You can send the cookie on the top level, and then you have service1.domain, service2.domain. They all get the cookie.
Okay, but they have to be all under the same domain.
Yes.
Yes, otherwise it doesn't.
Yeah. Otherwise, you do not set the parameter. Yeah, right. In that case, you try not to have cross-site scripting vulnerabilities.
I just thought in the era of microservices and everything, we have like a very large network where every other service runs on a different domain, then this wouldn't work. You just need to, your client that has to have this, otherwise you cannot send it anywhere at once.
If the government is your LocalStorage, right? It's more secure in a way. That's limitation. And in the to make out that it's proper, or it's for a moment, unless you can put in your discovery service and everything is under one domain. And everything is actually running down the whole ecosystem or in a way a whole right? Because then the platform becomes a problem. And the cookie it can be used this way.
So it's still your choice if you want to use local storage or cookies or something else. I can add, if you choose to, if you have this case that you want to query several APIs, and you store your token in local storage, let's say, and you send it not as a cookie but as a header, like authorization header. That's the advantage that you don't need anti-cross-site request forgery tokens anymore, because in that case, the browser doesn't send it automatically, so you don't need an extra protection for XSRF. But it has another drawback, is that in that case, you cannot get static assets easily. You cannot do get, yeah, like pictures and such.
Okay, well, thanks for all those questions. As always, you can come to the speaker for more discussions on local storage versus headers afterwards. And yeah, let's give him a big round of applause. Thank you.